to the new video. In this video, we will talk about the addition of organometallic reagents to aldehydes and ketones. So first of all, what are organometallic reagents? Organometallic reagents have carbon metal bond, have carbon and metal bond. Now in this video we will going to touch two organometallic reagents. So one is alkyl lithium and the another one is Grignard reagents. Grignard reagent. Now the alkyl lithium have carbon and lithium bond. Grignard reagent have carbon and magnesium bond. The lithium and magnesium both are electropositive, and hence here the carbon in both reagent, carbon have more electron density. It makes it more electrophilic. It makes it more nucleophilic as well as a good base, and hence it can act as base as well as nucleophile. So the first alkyl lithium we will start from is methyl lithium. Methyl lithium is just CS3 and I. Let's suppose lithium and we have CS3 bond. This is methyl lithium. Because here the carbon have more electron density, so on adding water in it or the presence of water, the methyl here takes the acidic proton from water and releases OH negative hydroxide ion, and here the methane gas release. This is just a acid base reaction. And hence we do not use water as a solvent if we just wanted to make this carbon as nucleophilic. So generally we use THF or ethers as a solvent for using the methyl lithium or alkyl lithium. So we use ether or THF as a solvent. For example, if we just start from the very first reaction, okay, let's suppose we have this compound acetophenone. So in the first step we add methyl lithium, let's suppose with THF as a solvent, and in the second step we will add H2O. So how this reaction work? See, initially to this ketone, the methyl lithium, that sigma bond breaks, and this methyl takes the electrons and attacks to the HOMO, which is pi star of this carbon group, leads to the breakage of this pi bond and the formation of alkoxide take place. Here a new carbon bond form. So another important thing with the Grignard reagent as well as alkyl lithium or organometallic reagents is that they will form a new carbon-carbon bond. New carbon-carbon bond. And in the next step, we will use this water molecule, which gives the acidic protons. So this negative charge of oxygen takes this acidic proton and we gains a new alcohol. Here this is tertiary alcohol. Okay, so if we just start from a new compound which is Grignard reagent, Grignard reagent can be formed by using alkyl halide or aryl halide. Reacting it with magnesium and using solvent as dry ether. So here the magnesium donates electron to this carbon and halogen, basically forms this compound RMgX. Here you will see that carbon and magnesium had a bond. That's why it is a organometallic compound. So here again the carbon have more electron density. So this Grignard reagent again can act as a nucleophile as well as a base. So because this have more electron density, this carbon have more electron density, we do not use it with water or any solvent which have acidic protons, because it just take the acidic protons from the water and leaves alkane, and in such cases we cannot have a nucleophile and nucleophilic addition or nucleophilic substitution reaction using Grignard reagent. So that's why we just use the dry ether. So as an example, if we start from this compound, let's suppose this is benzaldehyde. Let's suppose on adding C2H5 mgbr. This is a Grignard reagent. In the first step, that carbon of C2H5 attacks on this pi star, leaves the formation of alkoxide ion. Here we have two carbons, 1 and 2 ethyl. So in the next step we add water so that the alkoxides so formed get the protons. So it gives this is the phenyl. We can make it like pH. In this case we got a secondary alcohol. So this is up for the video. I hope you understand how the Grignard reagent and the alkyl lithium works. They are really good reagents for our organic chemistry, because they give us a reagent which can act as a base as well as a nucleophile, and we can make a carbon-carbon new bond on adding it on the carbonyl compound, mostly in aldehydes and ketones. So generally they are really very reactive, because carbon is not much electronegative and it easily donates the electrons to a electrophile or the proton, and hence act as a nucleophile and base respectively. Thank you for watching the video.